Hi guys, this is video 8.5. So this is PowerPoint 8.5 for Empirical Formula. And this is my joke of the day. If you get it, awesome. If you don't, just think about it. Okay, so I know that this says calculate empirical and molecular, but the molecular formula is going to be the next video. So you'll have to watch the next video in order to complete assignment 8.4, which is going to be due on Friday. Okay, so you need this video in the next video. All right, so let's talk about what molecular and empirical formulas are. So a molecular formula is the exact number of each element in a molecule. It tells you how many of how many precisely. So for sugar, you have C6H12O6. An empirical formula, on the other hand, is not the exact numbers, but a ratio of the atoms in a molecule. So for the same molecule, okay, if this is the molecular formula of sugar, then the empirical formula of sugar is the ratio. For every one carbon, there's two hydrogens and one oxygen, okay? You're just simplifying it. And you guys have experiments doing simplification. Okay, so for this video, we're going to focus on empirical formula, and we'll get into molecular in the next one. So talking about the simplest ratio of elements. So let's say that I give you the molecular formula of something like I did with sugar, C6H12O6. How would I turn that into the empirical formula? Well, you would simply reduce, okay? So, for example, what's the empirical formula of this molecular formula, H4S2O8? You just reduce this, and hopefully you get this answer. So this is the molecular formula, and this is the empirical formula, okay? So this is only if I give you the molecular formula. However, usually I won't give you the molecular formula, and you're just going to have to solve the empirical formula using some things that I give you. Now, you're going to look at this and say, Mrs. Teagues, there's 4 steps. And yes, there are 4 steps, but it rhymes. So that's something. All right, so 1 is percent to mass, 2 is mass to moles, then divide by the least, multiply till whole. Percent to mass to moles, divide by least, multiply till whole. I think Sophie could come up with a nice little tune for that. Okay. So here's our example. This is what it's going to look like, or kind of, okay? An unknown substance has this many grams of carbon, this many grams of hydrogen, and this many grams of oxygen. Find the empirical formula of this substance. Okay, so let's remember our little rhyme. Percent to mass to moles, divide by least, multiply till whole. You just have to memorize that, okay? All right, so 1 is convert percent to mass. Well, there are no percentages here. Well, sometimes that happens, and that means that if it's already in grams, then you can skip this step, okay? So if you don't see percents, skip step number 1, okay? It's already in grams. All right, then it's mass to moles. Now, here's what you have to remember for step 2, this. For step number 2, round to 2 decimal places. You have to. It makes it more accurate. If you don't, at the end, you could get the wrong answer. Sometimes it still works out, but sometimes it doesn't. Okay, so you're going to have to round step number 2 to 2 decimal places. So here's what so mass to moles is a fence post. You guys have done this in the previous lesson for the last quiz. So you can set it up like a fence post, or if you're not really interested in doing fence post, that's okay, but you must show me that you've divided by the molar mass off the periodic table. And notice I'm using 2 decimal places, and yes, that is important. So it's not just 12 anymore, it's 12.01 for carbon, okay? Grams and grams, so you're going to take the mass they gave you, divided by the mass off the periodic table, and your answer needs to be rounded to 2 decimal places. So we get from 49.28 grams of carbon, it now becomes 4.10 moles of carbon. So we're going to do that for the other 2. So hydrogen, again, notice I'm keeping 2 decimal places, 1.01, and I kept 2 decimal places in the answer. For oxygen, the number on oxygen is 15.999. That rounds to 16.00. I just didn't put the zeros in here, so that's the correct answer for that one. And then again, answer has 2 decimal places. All right, so those I've converted mass to moles. That's this step. And again, do not forget those 2 decimal places. All right, the third step says divide by the least. Well, the divide by the least means the lowest answer for here. So which one of these is the lowest answer? Well, I hope that you guys say that this one is 2.74. That is the least. You're going to divide each of these answers by this one because it's the lowest. Okay, so in the next slide, I have that here. So carbon was 4.10. I'm dividing it by that least number, 2.74, and I get an answer of 1.4960. So for this step, I'm really going to round to 1 decimal place. So step 2, I need to round to 2 decimal places. For this one, I can round to 1. Okay, and that's going to get me to 1.5. Okay, so for this one, I'm going to divide by the least, and I'm going to get 2.47. Again, that's going to round to 2.5. I kind of need to, let me see if I can write that in here. 10. No, it's not working. Oh, 2.5. Okay, and this is 1.5. Okay, and then oxygen divided by this, and this is just 1.0 with 1 decimal. Okay, you can keep 2, but you're going to have to round at some point for this one anyway. Okay, so step number 2 is when you need to keep 2 decimal places. All right, the last step is multiply till whole. So what these numbers represent, this 1.5, this 2.5, and this 1.0, these are going to be your subscripts. Well, you can't have 1.5 carbons. You can't have 2.5 hydrogens. You can have 1 oxygen, but if these guys don't work, then it doesn't matter, okay? So you need to multiply these numbers until you get a whole number, okay? And that's what the next step is. So here's how it goes. Whatever you do to 1, you have to do all of them. So even though this is a whole number, these guys are not, so you're going to have to multiply all of them. Because it's a ratio, you need to keep that ratio, okay? So if carbon's 1.5, hydrogen's 2.5, I kept it at 2.47, but that's okay. And oxygen's 1, again, whatever you do to 1, you must do to all. So then you're going to say, well, how did you know to multiply it by 2, Mrs. Teagues? Well, you want to multiply it by the least, okay? The lowest one first. Now, don't start with 1 because 1's not going to get you anywhere, but 2 might work. So 1.5 times 2, well, that's a nice whole number, okay? 2.47 times 2, that's going to get me to 4.94. That is close enough to call that 5. So that is a whole number. And then oxygen times 2 is 2, okay? So, if 2 doesn't work, so let's say it works for this one, but it didn't get you a whole number for this one. Let's just pretend that it got you to like 4.3. Okay, I know that didn't, but let's just pretend it did. Then 2 doesn't work. And so you go back to the drawing board and say, well, okay, if 2 doesn't work, how about we try 3 and 3 and 3. If 3 doesn't work, guess what number you try after 3, guys? 4. So, and so on and so forth, okay? Until you get a whole number for all of them. But again, it must be the least one because you want the lowest possible with all getting a whole number. So then what you do is you take these numbers, okay? And then they become your subscripts. So carbon gets a 3. So there's 3 carbons. Hydrogen gets that 5 right there. And oxygen gets that 2. And so this is our empirical formula, okay? All right, let's try another one. But before we do that, let's talk about percentages. So all the percentages in a compound have to add up to 100%. You don't need to worry about that because they will. But because they do add up to 100%, then we can assume a 100 gram sample, and then whatever the mass is the percent, okay? And so you're like, what, Mrs. Teagues? Don't worry, guys. I'll show you what I mean. So look. Here's our next compound, and I'm just giving you the percents here. So if step number 1 is percent to mass, okay, all you have to do, okay, is because these are all out of 100%, therefore it's all out of 100 grams, you just have to say that it is grams, and that's it, okay? That is step number 1, so it's 65.02 grams. You don't have to do any math for that, just say that it's grams. Okay, next step is mass to moles, but don't forget for step number 2, round to 2 decimal places. Okay, so for platinum, this is the molar mass of platinum. I kept 2 decimal places and I rounded my answer to 2 decimal places. Same thing for nitrogen, same thing for hydrogen, and same thing for chlorine. 2 decimal places, 2 decimal places, 2 decimal places, 2. This one was a 0, so it doesn't matter. And then, whoops, and then 2. Okay? All right, the next is, step number 3 is divide by the least. So which one is the least? I hope that you are going to say that this is the least, and it is. So we're going to divide all of these numbers by 0.33, okay? So that's what we've done here. So 0.33 divided by 0.33 is 1, right? 0.67 divided by 0.33 gives you 2.0. This one was actually 6.07 or something like that, which rounds to 1 decimal place. And this is acceptable to round to 6.0. And I'll talk more about that in a second. And then this one gives you 2. Okay, now you need to figure out, when do I have to round and when do I not have to round? So all of these are technically, so this is absolutely a whole number, this is absolutely a whole number, and this is absolutely a whole number, but this one, okay, there was a decimal place. How do I know when I can round and when I can't? All right, here's what you need to remember. If it is greater than or equal to 0, why is this not working? 0.9, okay? So if it is greater than or equal to 0.9, okay? So 0.91, I would even accept it, also 0.9, so 0.95, 0.96. That is okay to round. If it is less than or equal to 0.1, that is also okay to round. Anything in between that, so 0.2, 0.3, 0.4, 0.5, blah, 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 so on and so forth up until 0.9, you cannot round and you must multiply until whole. And that is why keeping those 2 decimals are important. Okay, so this is like super key. I didn't make a slide for that because I'm handwriting it. So 0.9 or greater, you can round that. 0.1 or less, so like 0.03. This was 6.07 here. So you can round that, that's okay. Or if it was just 0.1, which I rounded it to, you can round that to that whole number of 6, okay? So for the last step, all right, you multiplied till whole, but all of these were already a whole number. So the empirical formula was the number that we got. So there was 1 PT, so you don't have to put a subscript for that. There was 2 nitrogens, there were 6 hydrogens, and there were 2 CLs. Okay, remember these were the numbers right here: 1, 2, 6, 2. Okay, and so that's where we got these subscripts, and that's the empirical formula. Okay, so that is, I know that was a lot. There's 4 steps, although sometimes you can skip 1 or 2 steps depending on what they give you and how it works out. Please let me know if you have any more questions, and see the next video for molecular formula. Okay?